There is no national electrical code reference for an 8-foot height requirement regarding electrical installations. This means that the misconception of needing to install something above 8 feet for code compliance is inaccurate. It is important to understand the code articles and specific requirements that actually do exist, rather than relying on potentially incorrect assumptions. Electrical codes are in place to ensure safety and proper functionality. The NEC contains many specific requirements that must be adhered to concerning working clearances, overcurrent protection, grounding, wiring methods, and equipment installations. Firstly, working clearances around electrical equipment, particularly switchboards, panel boards, and motor control centers, are crucial for ensuring safe access for inspection, maintenance, and repair. Section 110.26 of the National Electrical Code addresses these requirements, specifying minimum distances both in front of and to the sides of the equipment. These clearances vary based on the voltage level and the presence of exposed live parts. For example, for equipment operating at 600 volts or less, the depth of the working space in front of the equipment can range from 3 feet to 4 feet, depending on the conditions. Condition 1 exists where there are exposed live parts on one side of the working space and no grounded parts on the other side of the working space, or where grounded parts are on both sides of the working space. Condition 2 exists where exposed live parts are on one side of the working space and grounded parts are on the other side of the working space. Condition 3 exists where exposed live parts are on both sides of the working space. Secondly, overcurrent protection is a fundamental safety measure designed to protect electrical systems and equipment from excessive current that could lead to overheating, fire, or equipment damage. Article 240 of the National Electrical Code covers the requirements for overcurrent protection devices such as circuit breakers and fuses. The selection and installation of these devices must be carefully considered based on the ampacity of the conductors they are protecting and the characteristics of the loads they serve. For example, a 15-amp circuit breaker is typically used to protect 14 American wire gauge copper conductors, while a 20-amp circuit breaker is used for 12 American wire gauge copper conductors. It is also crucial to ensure that the interrupting rating of the overcurrent protective device is sufficient for the available fault current at the point of installation. Thirdly, grounding is another critical aspect of electrical safety, providing a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices and minimizing the risk of electrical shock. Article 250 of the National Electrical Code outlines the requirements for grounding and bonding, covering topics such as grounding electrode systems, equipment, grounding conductors, and bonding of metal enclosures and equipment. A grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes, connected together to form a comprehensive grounding network. Equipment grounding conductors are used to connect the non-current carrying metal parts of electrical equipment to the grounding electrode system, providing a path for fault current to flow back to the source. Bonding involves connecting together all metal enclosures, raceways, and equipment to create an electrically continuous path, further enhancing safety and minimizing the risk of shock. Fourthly, wiring methods refer to the techniques and materials used to install electrical conductors and raceways. Chapter 3 of the National Electrical Code covers the requirements for various wiring methods, including non-metallic sheet cable, armored cable, rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Each wiring method has its own set of installation requirements and is suitable for different applications and environments. For example, non-metallic sheath cable, commonly known as Romex, is widely used in residential wiring for branch circuits and feeders. Armored cable, also known as BX cable, provides additional protection against physical damage and is often used in commercial and industrial applications. Rigid metal conduit offers the highest level of protection and is suitable for use in hazardous locations and areas subject to severe physical stress. Fifthly, equipment installation covers a wide range of electrical equipment, including luminaires, motors, transformers, and appliances. The National Electrical Code contains specific requirements for the installation of each type of equipment, addressing issues such as mounting, support, ventilation, and protection from physical damage. For example, luminaires must be securely mounted and supported to prevent them from falling or creating a hazard. Motors must be installed with adequate ventilation to prevent overheating, and transformers must be protected from overcurrent and overvoltage. Appliances must be installed in accordance with their listing and labeling instructions, ensuring that they are properly connected and grounded. These are a few of the many important areas covered by the National Electrical Code. It is important to consult the latest edition of the NEC and any applicable local codes and standards to ensure that electrical installations are performed safely and in compliance with all applicable regulations. Always consult with a qualified electrician or electrical engineer when designing or installing electrical systems. The absence of a specific 8-foot height requirement in the National Electrical Code doesn't diminish the importance of other safety regulations. Always prioritize safety and adhere to the guidelines outlined in the NEC and other relevant standards. Consider the type of electrical equipment involved, the voltage levels, the environment in which the equipment is installed, and any specific requirements outlined in the equipment's listing and labeling. While there isn't a blanket 8-foot rule, specific situations might necessitate high mounting heights for safety or functional reasons. For example, in industrial settings with heavy machinery or vehicular traffic, electrical equipment might be installed at a greater height to prevent accidental damage or contact. Similarly, in outdoor locations subject to flooding or vandalism, electrical equipment might be elevated to protect it from these hazards. Additionally, local codes or regulations might impose height restrictions based on specific circumstances or community need. Always check with the local electrical inspector or building department to determine if any additional requirements apply to the specific project. In conclusion, the absence of a universal 8-foot height requirement in the National Electrical Code doesn't mean that height considerations are irrelevant in electrical installations. Instead, it emphasizes the importance of understanding the specific requirements and guidelines outlined in the NEC and other relevant standards, as well as considering the unique circumstances of each project. Always prioritize safety and consult with qualified professionals to ensure that electrical installations are performed correctly and in compliance with all applicable regulations. By staying informed and following best practices, one can help create a safer and more reliable electrical environment for everyone. Remember to always consult the latest edition of the National Electrical Code and any applicable local codes and standards for the most up-to-date information and requirements. Staying informed and adhering to these regulations is crucial for ensuring electrical safety and compliance.